Good evening, everyone. I am back after a gap of 1 month with a new series, this time series number, webinar number 35, with a very interesting, very useful topic, which is usually not understood by many field engineers, that is the partial discharge. And today we are going to talk about the partial discharge fundamentals with a subject matter expert, respected Sudhanshu Gupta ji. When I say partial discharge, it is a kind of flashover of part of insulation system which is basically due to a localized electric field greater than the dielectric withstand capability of that particular part. However, the overall insulation system remains capable of withstanding the applied electric field. The one important crucial effect of this flashover is a high frequency pulse current that travel through the capacitance created by the insulation, entire insulation. We talk about different types of partial discharge we usually come across in the fields are corona discharge. It is because of the air emanating from the sharp edges of your conductor, accompanied by sound and radio frequency emission. Then comes the arcing discharge. It is prolonged effect discharge produced by the electrical breakdown of a gas. Plasma is produced with current flows through air or any other normally non-conductive material. Third important is the surface discharge, that is also known as the surface tracking. It is the most destructive types of partial discharge. It is because of the contamination and the weather condition, humidity. Last but not the least, the void. That is the internal fault due to the defects in the solid insulation of your cables, bushing, transformer, GIS, etc. It is highly destructive to insulation and will typically continue to expand until they cause the complete failure of my system. Now comes to the detection of that partial discharge I have already discussed. That can be detected by the four ways available: electric in terms of current and TEV, transient earth voltage, electromagnetic, radio, light and heat, acoustic, audio and ultrasonic, gases, ozone and nitrous oxides. In short, the PD can be detected by light, heat, smell, sound, high frequency current, electromagnetic waves, etc. I always start my all webinars with thanksgiving, and from the core of my heart, I would like to thank Almighty first, my family, my parents, my son. My mentors include respected PP Bhai Saab, Anjali Chandra ma'am, VK Rajput sir, who is already available, Dr. Kamal Bansal, KK Murthy Saab, NK Mittal sir, P. Ramachandran sir, S. Pau sir, Hitesh Chauhan ji, Arvind Tukral ji, and Sanjay Agarwal ji. When I talk about my friends and well-wishers, the first name comes with Saket Gupta. Umesh Gupta ji is there. Dr. Vikas Almari, Amandeep ji, Pradeep Garg ji. Last but not the least, my team working day and night to make this happen, Gulab and Ramdhani, and my supporters, EEC and Indian Association of Energy Management Professionals. Now, time to give a brief introduction about today's subject matter expert, presenter, Sudhanshu Gupta ji. He is a qualified engineer with 24 years experience in reliability improvement, condition monitoring, testing and diagnostics of power equipment or transmission and generation stations. He is regarded as the India's top most level technical expert of electrical equipment with experience of testings of more than 150 numbers of EHV class substations. He is involved in establishing new technologies and testing procedures and diagnostics of EHV electrical equipment like GIS, GIB, transformer, switchgear, cables, and rotating machines. He is also a member of expert group of GIS and distribution system of CBIP, that is the Indian chapter of SEGRE. He is also the author of CBIP GIS manual published by CBIP. He is the official trainer to India's largest transmission company, Power Grid, for partial discharge measurement. He is also providing training to India's top power utility like PGCL, NTPC, and HPC on PD and high voltage testings. He has also worked very closely with Crumpton Greaves in manufacturing India's first 800 kV transformer in establishing testing procedures and systems. Very good experience up to 1200 kV AC systems and 800 kV HVDC system he has. He has also established India's first true transformer loss measurement system as BHEL Bhopal and later followed by industries. Have also designed India's first high voltage mobile lab to test 400 kV class CT CVT, and that has already been supplied to CPRI. Established many high voltage labs and about 125 calibration labs, including 5 primary standards at Indian National Lab, National Physical Laboratory. Earlier, he also served in Qualitol company as a director. Now he is a CEO of leading fast-growing power solution providing company, Almond Systems Private Limited. Now time to give that platform to Gupta ji, and please share your knowledge and make everyone enlightened with the experience you have. Welcome, sir.
Thank you, Rajeshji. Can you just allow me to share my screen?
Yes, yes. Please share your screen.
Still, I think it's not allowing me to share the screen.
You are co-host. You have full right.
Is my screen is visible?
Presently, no.
Because it's choose Windows. Okay, Edge, entire screen. But the share is not, no, it's not allowing me to share.
You are the host. I think you are allowed. You look it again, sir. I'm also getting that option. That is a green icon at the bottom of your computer. Yes, now it's okay.
Is it sharing?
Yes, yes,
Is it okay?
yes, yes.
Okay. Okay.
Make it full screen, sir.
Thank you, Rajesh, and thank you all the participants, respected Murthy Saab and Sud Saab and other members. So today I'm going to discuss about the partial discharge with you all, and we will
Your voice is not coming, sir.
I'm so am I audible to everyone?
Yes, you are audible, sir. Please continue. Make it full screen. Yeah, it's okay. Perfectly okay. Kind
So
continue.
actually here I just want to discuss about the insulation. Because partial discharge, we are discussing a partial discharge, and partial discharge activity happens in insulation. And the simple thing is, voltage is directly proportional to the thickness of insulation, and current is directly proportional to the thickness of conductor. And we have three methods of testing insulation. We all know about the IR testing, C and tan delta testing, and the third is the partial discharge test. I wanted to highlight one fact that partial discharge testing doesn't mean that you don't require to do the tan delta testing. Tan delta and partial discharge both are very different tests. Partial discharge will tell you short time failure, like it will not tell you the health of your insulation. It will tell you that there is something wrong in the insulation, you have to take care of it. So it may fail and in a short time. So it will help you to predict the position of the insulation, the localized weakness of the insulation. Whereas the tan delta tells you the overall weakness or overall aging of the insulation. And we all know that 90% of the faults or 90% of the failures occur due to the localized weakness of the insulation. And that is the reason we see the infant mortality in the equipments also. And the main reason is the partial discharge. And partial discharge is an indication. It may not be the main cause of the fault. It's just an indication, and it tells you that something going wrong in your insulation, and you just correct it out. Now, there are many partial discharge detection techniques available nowadays, and I just want to highlight few the methods of testing. We all know about the chemical method. Chemical method is nothing but DGA and gas analysis in case of GIS. DGA, we all know, like almost all the utilities are depending on the DGA test. And DGA test tells you that there is something wrong in the insulation, but it will not tell you the type of the defects, and it will not tell you the location of the defect. So that is the reason chemical tests are being used as a helping tool. Then next, coming to the light detection. In light detection, there are many technologies evolved. Like for the corona testing, it's there, and the light detection techniques are also implemented in the GIS as well. But the main reason for these not being so popular because they require line of sight. So you should be able to see it. Then only you will be able to detect it. And the third and the most popular one is electrical testing, which we all know that the IC 6270 method testing. And it's mandatory to do this test when your equipment leaves the factory. The fourth point is TEV. TEV, I am just highlighting this, not just because it's again is a kind of electrical test, but it's a transient earth voltage. And so this kind of test is specifically used for some application like switch gears and all. Then we comes to the acoustic emission, which is again a popular test, and mostly it's being used as a tool to locate the partial discharge. Acoustic emission, I wanted to highlight one fact that which many people have thought that with the help of acoustic emission, they can detect the defects in the insulation also, which is not true. Acoustic emission is good for arcing, sparking kind of defects, but it is almost blind for insulation defects. And that is the reason it's used as a helping tool. And I'm also using this equipment a lot for in combination with other methods. Then comes to acoustic airborne method. It's again acoustic airborne is the difference between acoustic emission and acoustic airborne is acoustic emission is contact type sensor and acoustic airborne is non-contact type sensor. And acoustic airborne is being used for testing again arcing, sparking, corona kind of defects. And then comes to acoustic imaging. Acoustic imaging is the latest and the recent development in the field of partial discharge. Because here we have many sensors, like we use say 64, 100, 132 sensors, and depending upon the application, and it makes a cluster and it superimposes on a visual image. So then you will be able to locate the partial discharge activity. It's one step ahead compared to acoustic airborne, and very useful for transmission line and mainly for the composite insulator defects. And I have done many tests by using acoustic imaging, and it's very helpful in locating the defects. Then comes to ultra high frequency partial discharge detection. UHF nowadays has picked up the market because of its utility for GIS transformer, and especially for its field application, because it's almost impossible to implement IC 6270 method in field for transformer and GIS. And that's the reason we are depending more and more on UHF technologies for identification and early detection of partial discharge defects. Then coming to a radiometric UHF technology. Radiometric UHF technology is also, it's not a very old development. It's a recent development. Just it started back in 2005. And this is to detect the defects linked with the CT, CVT, and breakers in the switchyard, mainly for the air insulated switchyard. And it's being effectively used in many parts of the world. And in India also, we have done these tests successfully. And again, all these techniques need to be discussed separately. And now I'm coming to, let's skip this first. I'll come directly to, sorry, yeah. What is partial discharge? Because as our topic is mainly to understand the fundamentals of partial discharge, and that's the reason I wanted to give you a brief about the partial discharge. Although many of you people must be knowing it, but this is what was told to me, that to start with the fundamentals. So we are starting it now. As you can see in this picture, that there is a void. There's a void in an insulation, and as I mentioned that we are starting it, so we are giving you an analogy of void in this case. So we have a high voltage across this void, and because of this high voltage application, so the void will have some partial discharge activity inside. And once this partial discharge activity grows after a certain period, depending on the material parameter, it may give you a string in it. And after this string, you may have a flashover. And specifically, the insulation defects are not reversible. Like, it's irreversible. You know, you while testing equipments, you may find that the partial discharge was active, especially in a GIS. If you have a free particle, it was active, but you just switch off the that portion of the GIS and switch on. You may not find that partial discharge activity again. It may take some time to again start initiate it. But in case of insulation, in case it starts, then it will not go back. So it will persist, and ultimately it will enter into a failure mode. So in case you have an insulation defect, you should be always very, very careful. So now we are going to discuss the basics about how this the activity occurs in a void. So as you can see, there is a impurity in insulation. That impurity could be a void, and how it starts. So once you have a void in a insulation, so then when you apply a voltage across it, it will have a discharge channel. Discharge channel means like it will start. It will start at stress level. The stress will start in this insulation, and that's totally depending upon the size of the void. And size, orientation, there is so many factors involved in it to initiate the partial discharge. It's not like if you have even a very tiny void, it can start a partial discharge activity. It may start, but it may not be a dangerous. And that is the reason we have partial discharge. That is the reason we have partial discharge levels set in our system. Like for GIS, it's a 5 picocoulomb. For cable, it's a 5 picocoulomb. For CTs, CVTs, it's a 10 picocoulomb. And for transformers, it's 500 picocoulomb, depending upon the utility. Some utilities ask for 100 picocoulomb. And when it comes to generator, I would say even the 5,000 picocoulomb is okay. In generator, you can have a very high partial discharge also. So Once this activity starts, like your stress level develops, then the charge in the discharge channel reaches to a insulation surface. As you can see, here we have a positive. So this side, it will develop a negative charge, and the other side it will develop a positive charge. And the charge to the discharge channel reaches the insulation surface. They cause a field that reduces the stress across the cavity so that the discharge channel cannot be maintained. So it means like once this deposition starts, so you will have a condition that it will, once it reaches 3.3 kV, it will again a discharge. And as you can see, it's always occurs on the positive half cycle of a sine wave. And the specifically once you have a discharge, then automatically it's it will have a zero. Now the field across the cavity becomes zero and the discharge cannot be maintained. And in the negative half cycle, this will again build up in the same manner. So discharge channel will form, and this time the charge will be is opposite. Like if here you have positive, then in this side it will be a negative charge, here it will be a positive charge. And after this applied voltage, the same activity starts, like you have a discharge here, and then the next cycle starts. As you can see very clearly that this is a typical discharge method, like a methodology for the insulation defect. And ultimately, because of the different size, different type, and even in the discharge, the patterns, like we'll discuss later, the partial discharge, PRPD patterns and all, the patterns will be different, because this is one analogy like we are giving you that how it functions. So when the applied voltage continues, the charge until the stress in the cavity reaches the breakdown level and another discharge occurs. The charge are deposited on the surface of the cavity, because this is again repeating the same. We are doing the same repetition, as you can see, and it will continue like this. Now coming to the wave in the oscilloscope. The oscilloscope waveform will appear like this. The waveform showing how the voltage appearing across the cavity will change through successive cycle. And if you put it on the ellipse is formed when you synchronize the signal with the same frequency. The ellipse is formed in the oscilloscope. Like for partial discharge measurement, the synchronization is must, because then only you can place on the right quadrant. So this is the people who are involved in testing as per IC 6270. They know this ellipse very well, because this is how it is being measured for many years. And in the sine wave, it appears like this, where you can see the partially charged pulses on the rising trend on the voltage, like it's in the first quadrant and the third quadrant. Now coming to the equivalent circuit, like how it behaves. Like you have a insulation, and you have a x-axis, you have a y-axis. So the cavity is Z. So you have a equivalent capacitance Z. You have equivalent capacitance Y. and equivalent capacitance Cx. So this is the action of the discharge will reduce to zero voltage across here. Like once you have a discharge, like partial discharge activity means this capacitance will act as a impulse circuit. Like you have a switch kind of activity, it will switch on, switch off. So the moment you have a shorting in this capacitance, after the discharge, the charge will flow from Cx to Cy, Cx to Cy. So once you have a short, so capacitance will disbalance, and the current will flow from Cx to Cy. So again in the actual circuit where you have a equipment, you have a coupling capacitor, or we cannot blocking capacitance also. You have a coupling device. Coupling device Z means it can be a HFCT, it can be a balloon, it can be a shunt, anything. Like it depends on a test engineer what kind of sensors they use to decouple the partial discharge signal. And here it's actually a high voltage is applied. So this is kind of an equivalent circuit we used for testing as per IC 6270. The pulse when the discharge test object is connected to high voltage circuits together with the coupling capacitor. The input unit, coupling device Z. So in IC 6270, we have to calibrate the system always. The calibrate the system means once there is no voltage applied, then you inject a external calibrator, you inject a pulse so that you can know that what the partial discharge level. And this kind of activity we require in other kind of tests like other technologies, UHF also, but that's a totally a different method for testing, because there we have to correlate IC 6270 like picocoulomb to dBm. So that's a different method. So, but again, the calibration pulse is very important. It plays a very, very important role in partial discharge diagnostics. So the discharge calibrator simulates the action of a genuine discharge, but with known values. Now, coming to this is again a equivalent circuit where you can see the test object, blocking capacitor, partial discharge detector, Z impedance, voltage measurement device, high voltage power source. So this is a testing arrangement for a conventional partial discharge detection circuit. And this is all for today. And I would like to hear from you all, like how this is the basics which I try to explain, but I would be happy to get, take inputs from you, like what exactly you people wanted to understand or learn from me, so that I can prepare next time the presentation as per your problems.
Thank you
So,
very much, sir. Thanks a lot for this insightful presentation. I have many questions on behalf of all the participants, and I will also invite all the participants to ask the question one by one. And if you allow, I want to start some basic things.
okay.
Ramdhani, stop sharing that one. Just stop sharing, first of all. Kindly stop sharing from your side.
Yes, please go ahead.
Ramdhani, make it full. There is some issue.
Sir, kindly stop your sharing, sir, because your two windows are open.
Okay.
Yes, okay. For all the participants sitting here, I would like to add three fundamental things. When we say partial discharge and the persons who are in the field, They must have 3 Bibles documents. They must have that thing in their library. The very first document is IC 60270. That is about high voltage technique partial discharge measurement. Then they must have IC 60076 part 3, that is for the partial discharge for their transformer. That is the full case equipment. Then comes the secret document 444, unconventional PD measurement. Then secret document 654, that is the ultra high voltage partial discharge detection for GIS. Then you must have secret document 728, that is for on-site PD measurement assessment of high voltage EHV cables. Then comes IEEE documents. In IEEE C57113, the document that is required for your oil field transformer. Then come IEEE C57152, diagnostic testing of your oil field transformer. Then another very good guide is there, that is IEEE C57127. That is detection and location of acoustic emission from PD in oil field transformer. This was about the documents you must have. Then when we talk about the partial discharge, the most confusing thing is the unit used across world for the partial discharge measurement. Most of time when you are going for inspection, you always measure everything in picocoulomb, PC. And usually that already described very well by respected Gupta Saab. It varies equipment to equipment. Usually it is, for my GIS, we usually talk about 5 picocoulomb. And then comes, there another units are there, that is in basically dB. dB is nothing, it is a ratio, it is a log 10 ratio of your measure value to the reference value. Some manufacturers give that unit in terms of dB. In another documents, I have also seen many documents giving their report in terms of percentage. All these things lead to confusion for the persons in the field. This was about that I wanted to add. Now coming to ask very fundamental question. Sir, you have very wide experience in the field for the partial discharge measurement. My very first question on behalf of all the participants here is, out of many equipments you have already tested, what do you think is the most important reason, cause of partial discharge? Out of many reasons, what do you think is the most important, most reliable, most applicable cause of partial discharge in equipments we come across?
First of all, you have to specify the which equipment you want to
Yeah,
understand.
yes, let's say
GIS,
GIS.
GIS,
Yeah.
GIS or transformer. Okay. Okay. First of all, I'll let me pick up transformer and GIS both. Okay. When it comes to GIS, GIS installation in India, it mainly started like earlier. Also, it was installed in hydropower plants, but in transmission systems, it's mainly started in the year 2008, and gradually it's started becoming more and more popular. And the first thing which I wanted to highlight, that was installation commissioning of a GIS, because those days we used to see a lot of problems with the GIS, especially for the partial discharge activities. And because those days people used to start installation commissioning of the GIS without the hall was not ready, and even then they used to start assembling the GIS. That was the first reason, and that may the contamination may happen inside the GIS. That's first thing. Now coming to the type of defects. Type of defects, totally it depends on how it is being manufactured, how it is being installed and commissioned. So it's totally, I think it's a workmanship issue, and if there is any partial discharge activity. But the most important thing is how you can save it, how you can know in advance. Like once you purchase any equipment, any GIS, you must do a high voltage test with the partial discharge equipment.
True.
That time you will able to know many type of defects, and if your high voltage is passed, and if you have any partial discharge activity inside the GIS, it should be removed. And any means any, like in India still we give some leverage to OEMs, like even with the small partial discharge within 5 picocoulomb we allow, but it's not the case in Siemens, like in Singapore or Dubai. If they find any partial discharge activity, they don't allow. They ask OEM to remove it. Now coming to this type of defect which is serious and which are not serious. In GIS, if you find a floating component like floating potential, it can be like it can be there, and it will harm your GIS, but with the floating potential, you can survive for 10, 20 years without problem. Possibly. Like I'm not saying always, maybe. There are cases where even they have a very high partial discharge for the floating potential, but still GIS are working fine. And so floating potential is something is less dangerous compared to others. Others means free particle is really a dangerous thing. You never know when it will start, flying towards and it reaches to a position where you can have a flashover. Then there is another dangerous thing is protrusion. Protrusion is something I would recommend for protrusion, even if it is 1 picocoulomb, like even if it is very, very low, equivalent to 1 picocoulomb, I would be interested to remove it from the GIS. Because during the switching event, especially if it is in the breaker compartment, it should be taken very seriously. So, because during the switching event, it can give you a flashover. Okay, now coming to why it may happen. Because the partial discharge activity to enter into a flashover, it means your inception voltage to the breakdown voltage, that barrier is weakened because of that defect. So especially, and in protrusion is again two types of protrusions are there, on the enclosure and on that conductor. So if it is on the conductor, it should be taken very seriously. Now coming to insulation defects. Insulation defects are very, very important defects. If you find any insulation defect in your GIS, observe it. You have to track it continuously. I would say if it is not high, then you should do it on the weekly basis, and because it's guaranteed that it will give you a flashover. An insulation defect cannot be detected by using acoustic method. Only UHF technology can detect these kind of defects. Like acoustic is blind for insulation defects. Yeah.
I would like to say one thing here. You have talked about different sources and types of defects in my GIS.
Mhm.
As a utility, I can express the point of view of utility. There are two things are there. One is regular testings of PD, that is to, and after testing is over, how to pinpoint the fault that you are talking about. Because
Correct.
we are getting many kind of PRPD patterns, and you need some guide, you need some library, you need some software to pinpoint the fault and location of that fault in the GIS. And after pinpointing the fault, you have to take the corrective action.
Correct.
And after corrective action, you have to again monitor it. It is not like SFRA you have to do at the factory level. Then when a transformer or GIS transformer reaches the site, you have to perform it again. That becomes your signature. For PD, I think there is as such no signature is there. Even if you perform that high voltage PD during commissioning, it is not guaranteed that in future it is not going to occur. You have to monitor it regularly.
True,
And
true, true.
after doing the regular maintenance and testing, you need some expert advice to understand the type of fault that has developed, and accordingly you have to take the corrective action, if I'm not wrong.
True, true.
And
Okay.
how to sort out that issue of need of expert advice here.
Okay, I'll explain. Um, it's easy as far as GIS is concerned. Easy means I'll take it 2-3 steps. This discussion. Um, Specifically, GIS has having is very specific design. Like you have a 400 kV GIS of X make, maybe Siemens, maybe Xeon XD, NHVS, or a Japanese GIS or a Korean GIS. The design philosophy of GIS are mainly two types. One is a Japanese design, another is a European design. There is no American design exists today. There are some Russian designs earlier, but they were not popular, so they just killed, died. So we had many different designs earlier in the industry. Like ABB is having their own design. Um, Alstom now, this is GE. Alstom is having their own design. Then Siemens is having their own design. So today we can say that only live designs are from ABB. Now it is Hitachi. Uh, Alstom, now it is GE, and third one is Siemens. So before that, from Europe, there was VATech was there, Marlin-Gerin was there. So there are good suppliers. Similarly, in Japan, Fuji was there, Hitachi is there, Mitsubishi, and Toshiba. So when we see the designs of Korean manufacturers, Hyosung and Hyundai mainly, Hyosung Hyundai borrowed the technology from Japan. They don't have their own technology. When it comes to Chinese, in China they have three major players: Xeon XD, NHPS, and third one is Pingao. So Pingao design is Toshiba. Xeon XD was initially earlier. Their design was borrowed from Mitsubishi, and NHPS from Hitachi. So this I'm talking about, say, 15, 16 years ago. So NHVS design, why I'm discussing the design philosophies, because everyone is having their advantages and disadvantages, and type of defects and reliability factors, if we talk about. So when it comes to different manufacturing equipments, so everyone is having a different peculiar design. So you have to understand how to test those GISs. So I'm you're 100% right. Like the designs ultimately defines the different testing methods. Basic method is UHF, but the sensors will change.
Right.
The sensors will change. The type of sensors will change, and the selection of sensor you require some understanding about it. Now, the simple thing is when you why UHF was selected for GIS compared to acoustic and IC 6270? That's first question. The It's because of it's easy to use. It's easy to use. In the push was not from the OEM side. No OEM wants to monitor their GIS. Everyone wants like the GIS utility buy it and they just keep it. If they have failure, they'll call us, we'll repair, take more money. So the technology, like the maintenance thing, it started by National Grid UK because they asked the universities to help them in understanding and designing a system where they can, because GIS is a closed cube. You never know what is happening inside. And they had many failures. And because of the many failures, they wanted to test it somehow. And that's the reason the technology, UHF technology, came into picture. The advantage of UHF technology is it's more sensitive than IC 6270. It's highly sensitive. Because it's highly sensitive, then you can detect a very small partial discharge also. Like you can detect 5 picocoulomb without problem. Number two, it's immune, as like signal to noise ratio is very high. Why it's high? Because most of the environmental noises, they are below 300 megahertz. So when we talk about the noises in the air, so they die near about 300 megahertz. Whereas in the UHF, we start measurement
Gigahertz.
from 3 megahertz and towards like 1500 megahertz to 2 gigahertz.
Right.
So that's another reason, like why it's become popular, because people started getting better results by using UHF method and clear patterns, because without patterns, you are not sure whether it's a partial discharge or a noise. I wanted to highlight one fact is, um, it's not easy to become expert in a day or two or by attending any lecture. It's not easy. Like there are companies selling their lectures. Like you attend 2 seminars and you become expert of partial discharge. That's not possible. But still, with some training and with some good softwares, because good softwares, like I work for a company, they developed a software, and still working for a company, they have developed some expert software. So the first level of detection of partial discharge or first level of analysis is possible. Like it's an auto analysis. So the software based on the AI, artificial intelligence, and advanced neural network, so they provide you the first level of indication, like there is some fault and it is indicating that this defect is linked with the insulation defect or a free particle, because it's based on the database of millions of data. And so for a utility, it's easy because they have a software. By using that software, they can detect the type of, like they can detect partial discharge as well as they can classify it.
That was
Then coming
part of
to
GIS. Now coming to the part of my transformer. In transformer, what do you think is the most applicable regions for partial discharge? What are the effective regions of getting or creating discharges, partial discharge in transformer? Is it manufacturing defect, contamination, or something else?
I would not say manufacturing defects specifically, because because most of the transformers I have tested, they were old. Uh, I haven't tested because usually people call me for all critical jobs. I'm not getting any day-to-day job. I'm receiving only critical jobs. So most of the transformers I receive for testing, they are old, and they that those jobs comes to me when they have to take a decision, when they have to take out the transformer or they have to keep it, like they have to open it or they wanted to keep it. So that's so I would say, I'll just give you one recent example. I have tested one HVDC transformer. That's very interesting thing. I would like to highlight. um, in HVDC, it's very complicated because you are not handling just partial discharge of the insulation. You are handling, you're actually have to handle the noise created by the thyristor pulses also. So then it becomes more, complicated, and you should be very accurate in synchronization. Because if your synchronization is not proper, you will not be able to isolate those pulses, because we are getting a lot of pulses. So usually I do the mix of technologies. I use UHF, I use acoustic, and different type of sensors. Then based on that, then I do the prediction, and like this transformer has this defect, and this is the location. So, and I always rely on the patterns, what pattern is there, and try to cross verify by using different technologies. We have developed our own sensors also, that's developed by me, and we use those as well. It's totally, yeah.
You have talked about the pattern. When we talk about the pattern, there are two types of pattern we usually come across, PRPD and PRPS. What is the basic difference between the two pattern?
Okay. A very, very good question, I would say. Extremely good question, because usually people don't ask these type of questions like you have learned about it then, I would say. PRPS is, I'm really fan of PRPS. PRPS is phase resolve pulse sequence. This is a three-dimensional pattern which is formed from a 1 second data. 1 second data means 50 cycles.
Two.
So PRPS, because it's a three-dimensional and it's a pulse sequence, so you see the live pulses, like how it's behaving. I'll just give you one recent example come across to me at a power grid substation. My engineer was at site, and he was conducting one test. So he saw some, like the GIS was absolutely clean, absolutely clean. At one portion, he found some pulses, and then he sent that data to me. That was a PRPS data. And in PRPS data, because it's a real-time data, continuously, so then after checking that PRPS data, I said, it seems to be like a partial discharge, but your equipment is not synchronized. Because in PRPD, it will look like a noise. Because PRPD is a two-dimensional pattern.
Yes, these are basic difference.
Basic difference. It's a two-dimensional and it's a three-dimensional difference. PRPD, there is no limit. You can have a pattern for 5 seconds, 10 seconds, 50 seconds, 1 minute, 1 hour. There is no time limit. So PRPD means you must have a sufficient data so that you can create a pattern, so that you can predict the type of defects. You can classify it. So PRPD, there is no fixed number. So if the number of pulses are low, less, like if I say the PPS is pulse per second is only 4, 5, or 10, then I would say I will do it for, let's say, 30 seconds minimum. I will capture the 30 seconds data so that I can have a proper pattern. I can do more, but 30 seconds at least, or 50 seconds data is enough for detection. Then in that case, I asked my engineer to check the sync circuit. The sync circuit of the high voltage source was not working. Like the connector was broken from inside. So although from the external size, it looks like the synchronization port is available, but from inside it was not connected. And that's the main reason that we were not getting the proper pattern. So then I asked him to check ask the OEM to provide him a sync signal at least. So then they did some jugaad. They took that from the measurement circuit. They just took some in between some coil. I will say this is nothing but a transformer. They just provided a transformer, and then he was able to synchronize his, and we got a beautiful PRPD pattern of a floating component. And so its synchronization is very important, and PRPS and PRPD, I would say the both patterns are very important for testing.
Last question from my side. In your slides, you mentioned about the external calibrator. That is basically pulse generator,
Yes.
if I am not wrong.
Yes, pulse generator.
And the last question, You mentioned about acoustic airborne and radiometric UHF technology. Are you using it anywhere in India? I haven't seen it.
Okay, radiometric UHF technology. I am having one equipment with me, and NTPC has bought that product long back. The main problem is it's not, huh?
Are they using
NT,
it? NTPC?
no, they're not using it.
And what
Uh,
about airborne acoustic and imaging acoustic?
okay, I'll explain. First, radiometric UHF is complicated to operate. That's the reason people are not using it. Complicated means it's tough to operate. It requires skill. You have to develop a skill to operate it, and that's the reason because it's a beautiful equipment. You can pinpoint the defects in the AIS, but it's tough to use. That is the reason it's not becoming popular. People bought it, but since they were not able to use it, it's kind of a dead case. I have that equipment with me. Now coming to this acoustic imaging. Acoustic imaging is extremely easy to use product. Extremely easy. You don't need to be an engineer to operate it. Any ITI or a 12th standard
I,
student can
I
use it.
think utilities are not using it.
They have started it now.
Okay.
NTPC have started buying it. NLC started buying it. It will become more and more popular.
And where to use airborne? Acoustic airborne.
Airborne acoustic is not a new technology. It's pretty old technology. Acoustic airborne is being used for surface tracking. Like you have cable surface tracking is there. Then see, acoustic means anything which is on the surface, you can measure it. If it is inside the insulation, you cannot measure it.
Sir, all these
So
methods that you described are covered by IC 60270 or
no,
any document?
it's alternative IC is there.
Okay.
6270 is purely electrical.
Okay. And the cigarette documents for any methods you
Sigre is there. Sigre has done a lot of work in this. I would say the um, I would say the different technologies are available, but the testing engineer should be very clear which technologies to be used in which equipment, because people started thinking that they bought one equipment, like with the ultrasonic method. Ultrasonic and acoustic airborne is same thing.
Okay.
So if they bought one ultrasonic product, they can use it anywhere in switchyard. It's not possible. I have seen tenders by and from a reputed organization. Like if they ask, they wanted to test a transformer by using ultrasonic method. That's impossible because transformer is a closed box, metallic box, and acoustic airborne sensors are like condenser capacitor. So it's a capacitive, sensor, and it's a condenser. It's a mic. Acoustic airborne sensor is nothing but a mic. And again, the frequency range is different, but the basic it's manufactured like a mic only. Whereas people get confused with the acoustic emission and acoustic airborne also. Acoustic emission sensors are piezoelectric sensors. They are very similar to the vibration sensors we know. It's a piezoelectric sensor and it's a contact type sensor. So one should be very careful, especially in transformers, when they are using acoustic emission, because if the transformer vibration is high, you may end up into getting wrong results.
True.
And most important thing, transformer will vibrate with your power cycle only. Like the vibration, when you put a pattern, PRPD pattern from the acoustic emission sensor, it will exactly look like a partial discharge. No difference. So these are some typical and peculiar type of defects when the experience counts. My suggestion to new engineers is they should 90% of the time people think that it's very difficult, we cannot handle it. But I would say if they keep starting using it again and again, they will automatically learn it. Like I am, my experience when I started my career, especially in the partial discharge back in year 2000, I was utter idiot that time, I can say. I was not having any clue about partial discharge at all.
The idiot to intelligent journey.
So, so I was not able to understand any pattern. I was not able to understand anything in partial discharge that time. But it's a slow journey. But
as we are running out of time, I would like
yeah.
to take 2-3 questions of the audience.
Mhm.
Mr. Sundar Das Saab has raised hand. Kindly unmute and ask your question, sir. Sorry for making delay.
Hello, Das Sab. Hello.
Sir, kindly unmute. I have allowed you to unmute.
I have to unmute?
No, no, no.
No. Okay.
Das Saab has to ask question. Kindly switch on your camera first. We want to see your face. Then ask your question. Ramdhani, kindly unmute him.
Sir, I hope Das sir is not listen our words, sir.
Okay, okay, okay. Any other question from any audience? We are ready to answer your question. Yes, yes. Respected Davis, sir.
Namaskar, Davis sir.
Ramdhani, unmute, sir.
Yeah. Am I audible
Namaskar,
now?
sir.
Yes, yes.
Yes,
Namaste,
you are
namaste.
audible,
Thank you.
sir.
Thank you, sir. Thank you, sir, very much.
Okay. Audible, sir. Yes.
So, thank you, Dr. Rajesh, for arranging this program. I was excited to connect with Gupta ji after seeing his expertise in this field of specialized field of PD testing. Because normally, because I have spent more than 35 years in Siemens, but then very rarely I come across experts doing PD because up to 220 kV, 400 kV level, we have not been doing it regularly. Now, thank you very much to connect with you, and in future also, if something there, I will connect with you. Now, I will just ask, I have one or two clarification. I know I may be asking very, very basic questions with respect to PD because it is again a very specialized topic. Now, you talked about GIS, you talked about transformer, you talked about AIS switchyard. Now, how if I take a common voltage of 400 kV and GIS and also a transformer of 400 kV by 220 kV or AIS switchyard is also 400 kV. Now, what is the frequency of this test? Is it you do it? What is the frequency you keep it for this test?
So different technologies have different frequency. Like if it's acoustic airborne, it's only 40 kilohertz plus minus 1 kilohertz. That's a narrowband measurement. And
no, the frequency. I mean the frequency of testing. How at
no,
what
yeah,
duration?
so it's a okay frequency of duration.
Oh, sorry,
Okay.
I use a wrong
Okay.
terminology
Okay.
here because yeah.
Okay, duration depends upon the type of defect.
Okay.
Okay, like I'll give you an example. Like talk about transformer.
Okay.
In transformer, if you're not having online partial discharge installed, and believe me, no one is having online partial discharge installed. One or two customers, except like in India, people are not using online PD monitoring at present. If you don't have online PD monitoring equipment installed in the transformer, then if you're doing it periodically, so usually people do it when they see some DGA result, like gas in the transformer.
Right.
So if you find some gas in the transformer, you can conduct a test. So it depends on the gas, if it is stable or it's increasing.
Okay.
So if it is increasing, then you have to repeat it once in 6 months so that you can know the severity, because DGA cannot tell you the exact, like, although it will tell you many things, but it
Right.
cannot tell you the severity of the partial discharge.
Very right, very right. So, and what will be the cost of this one testing equipment? What you, I mean, for 400 kV, what is the voltage you apply? I mean,
I am doing online monitoring mainly.
okay.
I'm not doing any offline.
Okay.
First thing is, transformer cannot be tested offline, because from where you will get the source.
Okay.
There is one wrong practice recently I have heard in the industry. Recently means like I have visited some place where I was inquired by a guy, like, are you doing offline testing also? I said, how you will do the offline testing? From where you will get the voltage?
Right, right.
Then he said, from the 10 delta equipment, I can do the offline testing. I said, 10 delta is just 12 kV. How you will stress the insulation of a
Right.
220 kV transformer?
Right.
So that kind of misconcepts are there. And okay, Rajesh, you wanted to ask something.
Yeah, on behalf of utility, I can answer your question. First,
So thank you, sir. Thank you very much.
Transformer. For transformer, that is on SON basis. Basically, when you are getting rate of rise in the acetylene in your DGA, and you are not able to identify the fault, then you go for the partial discharge testing of your transformer. That is not based on any frequency, that based on the requirement, and it is linked with your DGA analysis. Second, for GIS, yes, there are two types of kits are available. One is online, second is a portable. For portable, their duration is usually 2 years. In every 2 years, you have to perform PD of entire GIS and you have to keep the record as per the standard operating procedures of utilities. Usually, it may vary utility to utility and depends on the criticality of your GIS. If once you have faced some problem in your particular section of GIS, in that case, you have to increase the frequency of that testing. It is not 2 year in that case. Third, the power cable and insulation joint connecting to a GIS or your AIS, that also need partial discharge testing based on the requirement. That must be done.
Okay. Thank you.
Thank
you very much.
I'll add to one more point in this. Acetylene alone is no more an indication for partial discharge in a transformer. Acetylene alone. If there is acetylene, yes, there is a partial discharge. Acetylene alone is not the indication. You have I have case studies where you have only hydrogen and
There are
CH4.
three main key gases are the hydrogen, acetylene,
and
methane.
CH4.
Yeah, in that case, you have to take the action. Main is for electrical discharge, the main gas is hydrogen. If the rate of production of that hydrogen is quite more, and by taking action, you are not able to stop it, that means some discharge is there. You have to pinpoint it, you have to identify it. That based on that thing.
Yeah.
Thank you.
Okay, now, Das Sab, you are available.
David Sab, and
Yes,
which
sir.
factory you were there?
I have spent 35 years in Siemens, so I have been there almost everywhere.
Okay.
I started as
never met. We never met.
yeah, so I was not in factory. I was in projects, started with the projects and then moved into various sites for commissioning and then later on into corporate safety and so on.
Okay.
So I will connect with you.
Because because Rishi Magan and we did the India's first GIS conference.
Okay. Yeah, understand.
With Rishi.
I know. And the first GIS was installed by me in Mundra port.
Okay. Great.
Yeah. Okay. Thank you.
Das Sab.
Thank you.
Yeah. Namaskar. Namaskar, Rajesh ji and Sudhanshu
Namaskar,
ji.
Das Sab. Namaskar, Das Sab.
Actually, मेरा signal थोड़ा break था, traveling from office to quarter. Actually, to Saturday also are having office.
Okay.
Okay. Well explained. Just I am having some simple and fundamental confusion. Rather, basic thing is that partial discharge is always there. There not it is means available or it is understood. Partial discharge And then comes to it changes in capacitance, what I understood from it, that give rise to changes in capacitance between that live and earth. You are
Okay.
measuring through this. Suppose in case of generator, sensing point is the outside the generator through the blocking or coupling capacitor. Means you are measuring the changes in the capacitance, the good one and the discharged one. That is the
Carry on, carry on. Hello.
and
Carry on. Hello.
There is some signal issue at his end. In the main, in the
Okay.
main, let's invite another expert on the PD, Jayesh Patelji. Now 2 experts will be 1-to-1.
Okay.
Patelji, you are allowed to ask your question.
Yeah, good evening, Sudhanshu ji. It was a
Good
nice
evening.
enlightening lecture. Now,
Okay.
there are two important factors which generally industry is ignorant about, or the misconceptions. So, since you are an expert, so I would like you to help us out and understand.
Can you switch on your camera? We want to see your
I
face.
was trying, but yeah, now it is. Earlier it was not. Is it
Yeah,
on
yeah.
now?
Yes, yes.
Yeah,
It's
great.
on, yeah. Tell
Yeah.
me.
So, namaskar, sir.
Namaskar.
Two things. One, in case if you don't have a UHF sensors in transformer, then whether IEC 60270 is a recommended practice, because since you have quite a lot of experience, you can help us understand how do we do it, because that is all old transformers do not have a UHF sensor. So that's an boiling question. And
Okay.
second, in GIS, everybody performs UHF measurement, but certain utilities who have already specified time of flight measurement, but are quite ignorant on the benefits of time of flight. So that is where they really don't know whether time of flight is important. They should select whatever they have mentioned, or they just they just neglect it because of the pure pressure of the suppliers that this is not important. So if you can help us understand these 2 points, I think it would be really good for the audience and for me personally also.
Okay. First of all, your question was IC 6270 implementation at site. Okay, so IC 6270 at site means most of the time it leads to a wrong results. I'll give you one example. Recently, I'm not sure, I forgot. There was a LinkedIn post recently. There was showing some partial discharge test in a transformer by using IC 6270 method, and the partial discharge level was about 12 nanocoulomb, 14 nanocoulomb, 15 nanocoulomb. Okay, 12, 14, 15 nanocoulomb is so high partial discharge activity that the transformer cannot sustain it. It will blow up. So ultimately, why it is happening? Because it cannot. Just imagine in a transformer factory where you have a controlled environment, it's tough for the transformer factory owners to conduct a IC 6270 test in the control environment. Then how you can do that at site easily? And that's the reason the data we receive, or most of the time, in Europe, if you have you are at a remote location where everything is quiet, your all neighboring equipment, so you have just one transformer, you have it's neat and clean system. There maybe they may get some results, but most of the time it's misleading. So that's one question, one answer to your question. And specifically, I can tell you, like, because or 14, 15, or 12 nanocoulomb. Nanocoulomb means 1000 picocoulomb. So the pass level of a transformer is 500 picocoulomb only. If a transformer is having 15,000 picocoulomb, will it survive? No, it will not. So first question is, your Buchholz relay should operate at that time. So that's the reason. That's IEC cannot be implemented at site at all. Because that's my long experience, because I start in my company, I worked for Qualitrol. I was director Qualitrol, and my company, after looking to the different data, they started developing a IC 6270 equipment for transformer testing. And that's a PD Tech Switzerland. So Magar has bought a company, PD Diagnostics, and PD Tech and PD Diagnostics were partners once upon a time. So PD Tech was like Qualitrol pushed them for development IC 6270 equipment for field testing, and after doing many tests, they failed. And I was the only one who was opposing it. Don't waste your time in this equipment. Okay, now coming to, because I have done that kind of test a lot, and I know the difficulties. Now coming to your question, time of flight. Okay, time of flight is a fantastic test, and I support it, because with time of flight you can do wonders in GIS or even in transformers. Time of flight is a very important test. Like, time of flight means you're locating it, you're going to locate it. Just imagine you have an insulation defect, and as I mentioned, in acoustic equipment, acoustic emission is blind for insulation defects. Then what next? For location, what you can do next? But you have no other option but to do a time of flight testing for location. So time of flight, I support time of flight. And anyway, I'm always, say, like, to implement the right technology always. So for insulation defect, there is no other method for location fault with except time of flight.
Well, thank you
And
very much.
that I've already mentioned in CBIP manual, that for void and all, the acoustic emission will not work.
Sir, we are running out of time, and now time to say bye. And before I say thanks to you, I would like to invite KK Murthy Saab, the senior most person, kindly say vote of thanks and say something about the presentation today we had. KK Murthy Saab, kindly unmute. Ramdhani is available.
Yes, sir. Actually, KK Murthy sir.
Murthy Saab, are you here?
I'm not able to switch off. I mean, switch on my this speaker as well as the video.
Speaker is
You're-
okay.
you're-
Yes, we are getting
you're-
the voice. No issue.
So first of all, let me congratulate Mr. Rajesh Gupta, Dr. Rajesh Gupta, and Mr. Engineer Sudhanshu Gupta for presenting this very important and I would say a very important webinar for the practicing engineers, particularly who are in the fields. Of course, I have retired about 21 years back. At that point of time, it was not there. It was not there at all of course we mostly have this AIS. GIS is only in two places in Madhya Pradesh. So I do not have much experience of GIS, but yes, I have known about the AIS for quite some time. And now in Madhya Pradesh, they are having this partial discharge for CTs. So my question is, what should be the basic level for any equipment? For say CTs is particular, this partial discharge should be this much, and it should not cross the limit. And say for other equipment, say for CVTs, it should be like this, or say for PTs, it should be this much. But there is no such limiting factor in partial discharge. So far, anybody has been said. And I don't know, of course, they say that they have started partial discharge test in CTs, online partial discharge, but they have not come to any conclusion that which CT is behaving badly. And as you see, in AIS, you will find that most of the equipments are much older. You see, for say transformer, we believe that it should work for more than 35, 30 years, more than 40 years. So that has been there in our place. We have we had transformer of course, that was Mitsubishi make, which has given us service for 56 years. But and in the CTs, of course, we had that ASIA cities and Brownberry cities, and those also gave us good service for a long time. So later on, of course, they have been phased away. That's a different case. So supposing in transformer itself, if you see, there are as many as 6 to 9 CTs. You see, CTs on the HV side, then LV side, then tertiary also. So, this changing the CTs due to the partial discharge must be pinpointing which CT is bad or which equipment is bad, which should be removed out of this service. So that is one of the main thing I would like to get clarified.
Okay, Moti
Sir,
sir,
your words, and I promise all the participants that series will continue, and I will invite Sudhanshu Gupta ji again for the next part of this partial discharge. We have just talked about the fundamentals today, and the series will continue, and this discussion will continue. And I would like to thank everyone, and very special thanks to all my mentors and Sudhanshu Gupta ji. Thank you, sir.
Thank you so much.
thank you very much. Thank you very much.
Thank you, sir. Thank you very much.
I got connected with Mr. Sudhanshu Gupta the other day. I didn't know his caliber, and I had not heard about him. Of course, we had been confined to a particular state only. It is of late that I have given a platform to grow by CBIP director, Mr. P.P. Vaisa, Engineer P.P. Vaisa.
Thank you,
So
sir.
beg your pardon?
Thank you, sir. Thank you very much.
So he is the number one mentor